Hi YouTube, it's been a while. I've been moving house and you really find out the benefits of minimalism when you move house. Seems that I've become a hoarder, pack rat, and so on, and so I think one day soon I might get rid of a few things. Okay, so here we are back for another video. I'm going to do fractions today in my booklet, a YouTube course in Mathematica, and this is very elementary. All right, so if you're not after something very elementary, then check out one of my other videos. Okay, so let's get into it. Fractions. We are going to consider the arithmetic of fractions and all things necessary to learn about mathematics with regard to fractions. All right, so I find in my courses that even though we're doing many advanced things like, say, calculus, derivatives, ordinary differential equations, and so on, my students tend to be pretty bad with fraction arithmetic for some reason. Right? Some people just never mastered it properly. So if you're one of those people, why don't you just take some time and go over this with me? Okay, so what is a fraction? Well, it's a proportion of a whole, right? Okay, now how do we enter a fraction in Mathematica? So I'll go up to the palettes, Basic Math Assistant, and there's a nice little button up here, right about here. Okay, I'll just press it, and then I can now close the palette. All right, now let's enter a fraction. So how about 2/3? All right, 2/3. There we go. Now, what if we want to do something with this? Say, add 1 to this. All right, let's do that. Add 1, Shift Enter, see what we have. Well, look, Mathematica has added these two rational numbers together and given the result 5/3. Okay, now some people would write this as 1 and 2/3. Now, Mathematica likes to write it this way, all right? So that we're talking about 5 being divided by 3. All right, 1 and 2/3 is the same as 5/3. Now, I prefer this notation, right? Because when you write 1 and 2/3, it's a little bit ambiguous, right? You write it something like, you put the 1 and then you put the 2/3 next to it. And it can be a little confusing because it reminds you of multiplication. All right, so I don't like that. As a personal preference, I prefer this or this. Okay, so that's a basic fraction. Now, we've got numerator, and denominator. Okay, numerator is the top, denominator is the bottom. Now, you never want to divide by 0 with fractions because that gives a meaningless result. Okay, it's undefined. Okay, now what about equivalent fractions? So this here says 1/3 and 2/6 are equivalent, right? So basically the fractions are equal. They represent the same proportions of the whole. All right, how do we work out that they're equal? Well, traditionally you factorize the numerator, you factorize the denominator, and you cancel like or equal terms within that. Okay, I'm going to show you this. Now, let's go scroll down here. Now, look, Mathematica will just tell you straight away that those are equal fractions, right? Because we can, whoops, let's enter that again. I can just enter the fraction 1/3 and I can ask the question, is this equal to, by putting equals, is this equal to 2/6? 2/6. All right, and then I'll press Shift Enter and it should say true. Yes, true. Okay, so that verifies computationally that those two fractions are equal. Now, how should you do this if you are doing this by hand? Well, normally you would factorize, you would seek out the prime factorization of the numerator, the prime factorization of the denominator, and cancel like terms, right? That's the naive way to do it. Okay, a more sophisticated way to do it is to take the greatest common divisor of the numerator and the denominator. But that's for a little bit later. All right, so let's start by considering the prime factorization of 2. Right now, Mathematica has a built-in function to help out with that. I can write factor integer, all right, and 2, right? We all know that 2 is a prime number, so it will tell us, all right, let's have a look. So the result is brackets, and then another set of brackets, 2, 1. Well, what that's saying is that the prime factorization of the number 2, it's 2 times 1. Okay, now let's try this with 6. Factor integer 6. All right, it says 2 times 1 and 3 times 1. All right, in other words, 2 times 3 is 6. Okay, so we have found out that 2/6. Now look, I'm going to write in comment form here. All right, so I'll scroll down here, and this is not code, this is just comment. All right, this is equal to 2 times 1, and then I have 2 times 3. All right, and what I do, if I'm doing this by hand, I want to cancel the 2's. All right, so I would get my red pen out and I'd write a slanted line through the 2's, right? And that would tell me that what remains when I cancel those, what remains is 1/3, 1 over 3. All right, so I'll say 1/3. Okay, and so these are equal fractions because I have canceled. Now, a more sophisticated way to do the same thing is to take the greatest common divisor of the numerator and the denominator, and then divide by that GCD. All right, that is more sophisticated because there is an algorithm for calculating the greatest common divisor, and it's due to Euclid. All right, so this goes back to ancient Greece. But it's a very nice and efficient algorithm for calculating this, and we still use it today. So I'm not going to go into that algorithm. I'm just going to say to you that there's a built-in function to calculate the GCD. It is just GCD in uppercase, right? 2, 6, shift enter, and we see that the greatest common divisor of 2 and 6 is equal to 2. So what does that mean? Well, it means that 2 divides into both of these, as in 0 remainder, all right? 6 is divisible by 2, 2 is divisible by 2, and not only does 2 divide into both of these numbers, it is the greatest such possible number. Okay, so that's the greatest common divisor. And now what we do is we just divide the numerator by the GCD, the denominator by the GCD, and we're going to then obtain the reduced fraction that is equivalent to the fraction. Okay, so now that we've described that, let's try something more complicated. I'll copy a new fraction. Incidentally, I think if we just press Shift Enter now, it'll reduce it for us. Okay, so that's easy, right? But you really want to know how all this works, so let's carry on. Okay, so now let's let me think. 91 is composite, right? 91. Let's just check that. Okay, in case my memory is bad, I'll go prime q, which is another built-in Mathematica function. This is a question: is 91 a prime number? False. Okay, since it's false, let's try to factorize it. Factor integer 91. Okay, so this says that 91 is 7 times 13. All right, now let's get creative and choose a denominator that has 13 in it. So how about 39? All right, so here we've got 91 over 39, and we want to consider reducing this. Well, in Mathematica, I pretty much just press Shift-Enter, and it'll do that for me. But you can also do this with the GCD. So GCD 91 with 39. All right, we find out the greatest common divisor is 13. Okay, and then what we do is we then construct 91 over this GCD, and we want to know what is 39 divided by this GCD. Okay, we get 7 and 3, and then we form the fraction 7/3. Right, so that's how to reduce fractions. Okay, so let's move on and talk about addition of fractions. All right, so I'll scroll down here a little bit, and then I'll pull up the Mathematica window again. Okay, now if we are to add two fractions, what we need to do is get a common denominator. Okay, so let's go ahead and form, I'll copy this down here into a new cell. All right, so now I want to consider adding that to, let's add that to 5/13. Okay, why did I pick 5/13? Well, because I already happen to know that 13 goes into 39. Okay, so that gives me an opportunity to consider GCDs and LCMs, least common multiples. Okay, so what we want on the denominator is, I think it's the least common multiple, but I'll have a think about it while I'm talking. Okay, so basically, in order to add two fractions, you need the same denominator. Now this works for numbers, it works for algebraic expressions, so when you have an x and a y, an a and a b, etc. in your numerator or denominator or both, you still need a common denominator. Okay, so this is very important, even when you go on to algebra, calculus, and so on. Okay, so what we want to do here is ask ourselves, what number do we need in the denominator in order to make both of these denominators common? Well, the answer here is 39. And why? Because if we multiply 13 by 3, we get 39. Okay, that is also, yeah, I'm pretty sure it's the LCM. Let's try and see if there's a built-in function for this. LCM 39, 13. Okay, yeah, so it agrees, it's 39. All right, now there's a relationship between the greatest common divisor and the least common multiple. So, you know what, let's just go on Wikipedia. So I'll type in GCD wiki, I think. Okay, so it'll tell me the exact relationship. Probably need to scroll down to the properties. So here we see some properties of the GCD, but there are probably quite a lot more. Yes, properties. Ah, this is a little small, you can't see it. But what I'm looking for is, there's a relationship between the products. Okay, here it is, right here. Right here. Okay, so this says that the GCD of A and B times the LCM of A and B is equal to the absolute value of the product of A and B. So I'm going to copy that and paste that into this, because this is a fairly important property. All right, so I'm going to write in comment form. So LCM of numbers AB times the GCD of numbers AB is equal to the absolute value of A times b. All right, so that's the property here. What relates the LCM to the GCD and to the product of a and b. Okay, so we need the LCM in order to add two fractions. All right, now let's actually carry out the mechanics of this by hand. Okay, now that we know that the LCM of 39 and 13 is actually just 39, we can say, now I'm writing, I'm going to make this a comment, okay? So I don't intend to execute what I'm writing now. So I'll copy, and I'll paste, and I'll say what I'm doing is multiplying the denominator by 3, and in order to make this equal, I must also multiply the numerator by 3. Okay, so now that's the next line in our step. The next step. All right, now let's multiply that out. Well, we know this is 39, and this is just 15. Okay, now that we have that, we can place these numerators over the same denominator. So 91 plus 15. All right, and you probably can do this in your head. I think that's 106. All right, but of course you have Mathematica to check. Okay, so 106. Okay, do these have any common factors? Well, I happen to know that 39 is 3 times 13. That's the prime factorization. Whereas the numerator does not have a factor of 3, because 1 plus 6 is not divisible by 3, and also the numerator is not divisible by 13, so that should be a reduced fraction. But let's just check. Let's just check in Mathematica. Yes, that's reduced. Okay, so all good. We have added these two fractions successfully and reduced the result. Now, you should know that all of this works very well on Wolfram Alpha. Okay, so this is a phone app. Here's my phone. Good small phone. Fits in my pocket nicely. But when I'm out and about, I can check these sorts of things just like it's a calculator. And it's fairly inexpensive, so you can pick that up on the cheap, and you can do maths on the beach. All right, so yes. All right, so that's how to add two fractions. Now, if you have something, a sum of two fractions where the denominators do not have a common divisor, let's just choose another one. All right, so we'll go down into a new cell, and I'm going to pick, hey, what happens if I just choose 13 over 5? All right, 13 over 5 instead. Now, I know that 5 and 39 have a greatest common divisor equal to 1, so in other words, no common divisors. Okay, so what does that mean for getting a common divisor and adding these two? Well, what we have to do is get a common denominator, but that common denominator is going to simply be the product, right? And how do we know that? Well, you can just look at this property. If this number is 1, the least common multiple, which is the common denominator, is just the product AB, right? In other words, in this case, 39 times 5, and I'm going to get Mathematica to calculate that. 5 times 39, it's 195. All right, so let's do this by hand. So I need a common denominator of, all right, I'll get rid of the numerator. Common denominator of 195. Okay, now our numerator is, so what we're doing here is we're multiplying numerator and denominator of this fraction on the left by 5. So I probably need another step yet. So I'm going to make another step yet in between. All right, so I'll copy this. And I'll say what I'm doing is I'm multiplying numerator on the left by 5, denominator on the left by 5, and on the right fraction I am multiplying by 39 in the numerator and 39 in the denominator. Okay, now we know already that the denominator is 195, and that's common. Okay, these two denominators are the same. Now the numerators we need to actually calculate, so I'll come down here and calculate that. 455, so I'll write that here, and then plus this one, 39 times 13, so that's 3 times 13 squared, 507. Okay, 507, and now we need to add these, right? So I'll copy this down here, and I'll calculate that. Okay, 962. Okay, 962. All right, now we have added those fractions. Let's just double check if there's anything to reduce. Yes, there is something to reduce. We can probably divide a 13 out. Okay, let's just check while we're at it. What is the GCD? What is the GCD, greatest common divisor, that we are dividing out? GCD 962.195. Okay, the GCD is 13. So we're dividing throughout by 13. So let's include one more step. Okay, so this is divided by 13, and the denominator to be divided by 13. And what did we get? 74 over 15. All right, and there is our calculation complete. And now I told you I wanted to make this a comment. All right, so this is the kind of thing you might write out by hand. All right, and there we have it. Okay, so that's how to add two fractions. Now, what if they had some letters in them? All right, so let's just do a variation of this. All right, I'll come in here, and let's suppose that was 39A, and this one was 5AB, and then this up here was 91B. Okay, all right, now we have an algebra problem to simplify. We want to simplify this, add the result, and reduce the fraction. Okay, so what would we do? We need still a common denominator. So we want to, now what did we learn up here? That we need a common denominator of 195. Okay, so what I do here is I say I need to multiply numerator and denominator first of this left one by b. All right, so I'll just space b, and then this one will be b squared in the numerator. Right now the ab is common in the denominator, but I also need to make the numbers common in the denominator. So I'll multiply the numerator by 5, the denominator by 5 on that one, and in this fraction on the right hand side I'll multiply the numerator by 39, the denominator by 39. Let's just check. I did do that, right? Yes. Okay. All right. Now the the denominators are common. Okay. So what I can do next is simply add the numerators. Get rid of that. Okay. Now I've added the numerators, and I have an expression. The expression has yet to be simplified. Okay. So what we can do is just get some help with Mathematica. Let's just take this numerator, open up a new cell, press Shift and Enter, see what we get. All right, so that has simplified the expression. And now I can come down and write a new line in my comment as to how I am simplifying this. And so I'll say that I have 507 plus 455b squared. Now many of us like to put the b squared first, so let's do that. 507 And I'll get rid of that. Okay, now what about the denominator? So I know that that product of 5 times 39 is 195, so I don't need to calculate that one. Okay, now there's is there anything to cancel? Right, possibly a 13 to cancel. So let's try this. 455 divide 13. Yes, it's 35. What about 507 divided by 13? 39. So I can cancel a common 13 still in the numerator and denominator, even though I cannot add like terms in the numerator. Okay, so I've got one more thing to simplify here. So I'm dividing all by 13. So 195 over 13. Whoops. And we see that's 15. We already knew that. All right, what else did we find? 35 and 39. 35 and 39. Okay, and that is an algebraic expression fully simplified. All right. Now, to do with fractions, you also need to know how to multiply them and how to divide them. Okay, let's have a look how to multiply two fractions. Well, that's really easy. You simply multiply the numerators and the denominators. So I'm not going to go into a lot of details on that. Let's just copy this one. And suppose we had to multiply it by, say 2/3. 2/3, all right? Let's see what Mathematica says that product is. All right, it's 148 over 45. Now notice that 3 times 15 is 45, and 2 times 174 is 148. Okay, so what's happening here is we multiply the numerator with the other numerator, the denominator with the other denominator, and we get our result. Okay, so I'll copy a fraction. So what do we have? 74 times 2, 15 times 3, and then we find that that is equal to 148 over 45. Okay, and since 2 and 15 don't have any common divisors other than 1, likewise 3 and 74 don't have any other common divisors other than 1, so this is going to be already reduced, 148 over 45. Okay, now how about division? All right, so division. Now there would be this division symbol, which is a horizontal line with a dot on either side, right? That's what division. The division symbol. Yeah, goes back to maybe John Pell, round about that time. Okay, anyway, but it's probably best to think of this as this. So I'm talking about division, so I'm just going to enter a problem about division. So let's say to the power of -1. Right, now that would say 74/15 divided by 2/3. Okay, so if we press Shift and Enter, we can get the answer. All right, but how do we calculate this by hand? So I'll write this as a comment. Okay, so this, the one that is being divided into the other one. Hey, I probably said that wrong. Okay, this one here, the one on the right hand side of the divide symbol. All right, which in our case, we've written this as to the power of -1. So what you do is you simply invert, swap the fraction upside down. Okay, so this would be multiply by 3/2. Okay, and now this just becomes a multiplication problem, which is really easy. So we just have 3 by 74. So 3 by 74 and 2 by 15. Whoops, 2 by 15, not 3 by 15. Okay, but you can see that there are things to cancel in the numerator and denominator. So let's consider that. All right, so what I'm observing here is that 15 is 3 by 5, and 74 is, let's see, 37 by 2, or 2 by 37. 60, yeah, 74. Okay, and now you see you can get your red pen out on paper, cancel the 2, cancel the 3, and what remains is 37 over 5, right? Which is exactly what Mathematica gave us here. So 37 over 5. Okay, and that is that problem done. So let's turn that into a comment because that's what we were writing. Okay, that's fractions. Hope you learned something. Don't underestimate the importance of it. Okay, even though many people take it for granted as being very easy, so many people make mistakes. All right, so that's all I have to say about that for now. Thanks for watching, and I'll see you next time. I think we'll do some a fun video next time. We'll take a break from this booklet and do a fun video and then get back to it. All right, bye for now.